Here you're seeing a standard form of a quadratic. We know it's quadratic because there's an x squared term and an x term. And this is the graph. All quadratics have a graph that looks something like this. It's called the parabola. It's kind of a U-shaped graph. And, you know, just like anytime you graph something like in the form y equals mx plus b, you can expect some kind of line, whether it's uphill or downhill or super duper steep or super duper not so steep. These all look like lines. If it's got a squared in it, it's always going to look like some kind of parabola. Maybe it opens this way, up, maybe it opens down, maybe it's really, really wide, maybe it's really, really narrow. But anytime it's of the form y equals ax squared plus bx plus c, we're going to get a parabola. And that's the shape that you're seeing on the graph over in this area over here. This is standard form. Standard form means that we have an x squared term, and then any other term that has x's in it is going to go next, and then so it's like highest power term first. So first x squared terms, then x, then constant. That's standard form. There's a second form we're going to look at for graphing called the vertex form, and the vertex form of this exact same function looks like this. And if you don't believe me, you probably know enough math to simplify this. Like, you know how to square this portion of things. You could square that if you wanted to multiply by itself and then distribute the 2 and subtract 18, and you'd see this is the exact function that's like looking at you if you did that. But we're not going to do that. We are going to talk about how to take something that's in standard form and convert it to vertex form in the next couple of videos, but I just wanted to see what you were looking at. It's going to look like this. And the reason why we call this vertex form is because the vertex of the parabola is very easy to find. You know, you may not know what a vertex is. Parabolas all have this beautiful symmetry with them, right? It is used with vertical symmetry. And that turnaround point, that point right there, that point's called the vertex. That point's called the vertex. And in your most basic parabola, just y equals x squared, that vertex is going to happen at 0, 0. Because if you let x equal 0, y equals 0. If x is 1, you get a positive 1. If x is negative 1, you get a positive 1. If it's 2, you get a 4. If it's negative 2, you get a positive 4. So as you move away, you get the same y value, but this is the one place that they, you know, right smack in the middle, it's the vertex. We did some work earlier this semester where we shifted graphs around, like moved them. And I'll just point out that, like, basically, if I have this blue graph and it's way up here, that would be kind of like where the vertex is at 0, 0. And then this is saying so shifted 4 to the left and 18 down. If it's in vertex form, we can look at this as like shifts. And it'd be a shift of 4 left and 18 down. So if I were to take that parabola, whoa, that I just had grabbed a moment ago, and I were to shift it 4 to the left and 18 down, I'd be right back where I was, you know, just moments ago. So that's why we call it vertex form, because you can use shifts to tell where the vertex is going to be. So now let's look at how to take something that's in standard form and rewrite it so that it's in vertex form.